Assalamu alaikum dear students. Okay, last time we were discussing number of conjugacy classes in SN, and we also want to find number of elements in a conjugacy class. Though we have a very well-known theorem that number of elements in a conjugacy class of a representative element alpha is the index of its normalizer in Sn. So we have another way to find number of elements in a conjugacy class. For this we have a definition. Okay, see, size of a conjugacy class, this is our rest of the part, and we already have discussed for S5 these were the possible 7 partitions, and one was 5 one time and 2, and also see that if you have partition of this type 1 plus 1 plus 1 plus 1, it means this is against the identity, right? And if you have partition of this type 2 plus 2 plus 1, this means that its type is 1 2 3 4. I mean 2 permutations of size 2 cycles of size. It's also telling the cycle structure, cycle type of that permutation, which is going to be the part of conjugacy class corresponding to this alpha, right? This permutation. So see here, 2 plus 2 plus 1 is there are 2 cycles of length 2, right? And one is length 1, either you write or not, we don't have any problem. So if you want to write, it's a point, so point will never affect on any permutation because it is behaving like an identity permutation. Okay. Next, 2 plus 1 plus 1. So this is of the type 1 2 type permutation. All those permutations which are conjugate to 1 2 must be in this class, right? So 5 is 3 plus 2 means one permutation is of the type 1 2 3 and 4 5. You can also write like this. This can also be written as like this: 1 2 3 4 5. One is the same thing, means one is of 2. You know that addition is commutative, so you can write 2 plus 3. So this is the same 1 2 3 4 5, and 1 2 3 4 5 is the same class. You can write all these type in this class, right? Okay. So then 5 3 plus 1 plus 1. This is 1 2 3, a cycle of length 3, nothing else. Here cycle of length 4. All cycle of length 4 of the type must be in this class and must be conjugate to this one, and 5 permutation of the type 1 2 3 4 5, and all permutation of this type must be in its conjugacy class. Now the last question remains is what is the size, that how many number of permutation of the type in its conjugacy class, and how many permutation of the type in its conjugacy class, how many permutation of the type in its conjugacy class, and so forth. This is also is a wonderful quest that can you find number of conjugacy classes? Is there any other way? Yes, we have a computational technique again. Size of a conjugacy class. See, let P be any unordered partition like P5 7, and one of the partition, it may be this. It may be any of the partition, because every partition is generating corresponding element of S5 and telling its type, right? So P be an unordered partition of any integer n if P has nk parts of size k. You see here, 5 parts of size 1, 2 parts of size 2, 1 part of size 1, 1 part of size 2, and 3 part of size 1, 1 part of size 3, 1 part of size 2, 1 part of size 3, and 2 part of size 1, and so on and so forth. This is what I am saying. If P has nk parts of size k for every k, right? So suppose C alpha be a conjugacy class of the permutation alpha. Now, C alpha is the corresponding conjugacy class for which you are selecting a partition whose parts are nk parts. Suppose n1 part has 1 elements, n2 part has 2 elements. Nk part, but I am saying that nk parts of size k for every k mean that n1 has 1 part, n2 has say 2 part, n3 size n3 has 3 part, n4 has 4 part, like this. Of course you can arrange these, so no problem. There is only n1, there is n1 is n2 2, and then this has 1 part, n3, and so on and so forth. These are the parts, like this. You can understand. Of the permutation alpha, where alpha is a p type, you are taking that permutation for which this partition is in fact its cycle type, right? That is cyclic decomposition of alpha, and all those which are conjugate to alpha. Of course, because we want to find the size of a conjugacy class, so of course all those elements which are conjugate to alpha must also be of the same partition type, right? Is of p type. Then size of C alpha is n factorial over k power ak into ak factorial. Okay, let's elaborate this with the help of an example. Suppose n is equal to 4 and you have 4 is equal to 2 plus 2 plus 1. This means that there are 2 parts of size 2 and 1 part of size 1. Okay, so what is the formula? This is product n factorial, so 4 factorial, then 2 power 2 k power ak, k power ak. K is the number of this 1 2, 2 power 2 this number, this is ak size, ak is here 2, ak is 2, so 2 power 2 into ak factorial, this is ak is 2, so ak factorial, 2 power ak, here ak is 2, 2 power 2 into 2 factorial into, so next number is 1, and 1 power 1 into 1 factorial is in one number of one size, no problem. So if you simplify this 4, 4, 3, 2, 1, and what is this? 2 power 2, 4, and then 2, 4 into 2, these are cancelled, so this 3. It means that, what was this? In S4, so permutation of the type, the conjugacy class of permutation of this type has 3 elements. Okay, in S4, what I am saying, I have calculated corresponding to 4, right? And 4 is for S4 here. So in S4, a permutation of the type 1, 2, 3, 4, because this is 2, 2, 1, a permutation of the type, not, there should not be 1, because or you can say this is 5, take this is 5, okay, plus 1, then this should be 5 factorial, and then 2 power 5, and this is 5 factorial, and 5 and 3, 15, okay. It means in S5, permutation of the type 2 plus 2 plus 1, permutation of the type 1, 2, 3, 4, corresponding this element you have a conjugacy class, and in that conjugacy class you have 15 elements. You have 15 elements. So in S5 the conjugacy class corresponding to this permutation, or you can say of a permutation whose cycle type is this 2 plus 2 plus 1. Of course, it's corresponding to the type, permutation type is 1, 2, 3, 4. And if you find the conjugacy class of 1, 2, 3, 4, then its conjugacy class is 15. What does it mean? This means that there are 15 elements in S5 which are conjugate to this. There are 15 elements in S5 which are conjugate to 1, 2, 3. Let's elaborate this example one by one. Okay, we will see again and again. Okay, now take 5 is equal to 1 plus 1 plus 1 plus 1 plus 1. So the formula must be this is permutation corresponding to 1 identity. I already have told you that 1, 1, 1 stand for identity, 2, 2, 1 stand for 1, 2, 3, 4, and so on and so forth. So it means that you want to find the conjugacy class of alpha, where alpha is equal to identity. What is its size? The formula is 5 factorial, then aj, here aj is 1, aj 1, aj, what was this? 1 power aj, k power aj, this is k is 1, and k power aj, this is 5 power 1 into 1 factorial, right? Like this. Okay. Am I right? 5 power 1, sorry, this is 1 power 5 into 5 factorial. Because aj is the size 1, 2, 3, 4, 5. It's appearing 5 times. So 1 power 5 into 5 factorial, and this is equal to 5 factorial or 5 factorial. This is 1. This means that of this type you have only one permutation, so in its conjugacy class contain just one element. This is 1 itself, and you know that it is the central element, self conjugate, since the identity element is always the central element. Okay, next is if 5 is equal to 2 plus 2 plus 1, this type, then of course alpha must be of the type 1, 2, 3, 4, of course 1. If you write 1 or not, you don't have any problem because it's the identity element. So for sake of convenience, I am writing like this. This means that 2 permutation of size 2. 2 permutations. So k is equal to 2, number of permutations 2, and size is 2, aj is 2. So the C alpha here, say this is alpha 1, C alpha 1, size is 5 factorial, 2 power 2 into 2 factorial, right? So if you want to write 1 as well, so no problem, 1 of size 1, a part of size 1, okay? So 1 part of size 1 you have to multiply into 1 power 1 into 1 factorial. So this is 5, 4, 3, 2, 1, and 4, 2, and this is equal to, in fact, 4, 2, 2, 4, 15, yes. So C alpha 1. So the conjugacy class corresponding to this permutation and must contain 15 permutation. Then for if alpha, in the case, this was case 1, this was case 2, now for case 3, 2 plus 1 plus 1, 5 is equal to 2 plus 1 plus 1 plus 1. You have 1 of size 2, Okay, 2 plus 1 plus 1. 1 of size 2, this is 2 power 1 into 1 factorial. What is the formula? So C, say here alpha 2 is of the type 1, 2. Of course this is 1, no need to write 1. But they will contribute in finding the number of elements in its conjugacy class. That how many elements are present in its conjugacy class, you have to see. So C alpha 2 is equal to 5 factorial over 2 power 1 into 1 factorial into, now k is 3, k is 1, so 1 power 3 aj, its size. So aj is size, aj is the size, or ak is the size. We have used the word ak, right? So this is 3 factorial. What is this? This is 5 factorial over 2 into 3 factorial, which is equal to 5, 4, 3 factorial. This is 2, 3 factorial. These are cancelled. 2 to the 4. So 10. This means that you can label these are 1, these are 15. These are one element in its conjugacy class, contain one element, size of C alpha, and this conjugacy class contain 10 elements, right? Then 3 for 4, 4 is 3 plus 2. What is happening? You see, so for 4 you have 5 is equal to 3 plus 2. One part of size 1 and one part of size 1. So this is 3, k 3, here k is 3 of size 1 and k is 2 of size 1, right? So the formula is, say here alpha 3 would be equal to 1, 2, 3 and 4, 5. Yes, it is. Alpha 3 must be of the type 1, 2, 3 and 4, 4, because 1 is of size 3 and 1 is of size 2, right? So this is integer size 2 and this is integer size 3. So here k is equal to 3 and k is equal to 2 of size 1, right? So the formula is C alpha 3 size must be equal to 5 factorial over 3 power 1 into 1 factorial. So into 2 power 1 into 1 factorial. Because aj is the size, or we have written ak, ak or aj or ap, whatever you are using the index is ak. So ak is the size, that's why its size is 1. Okay, 3, this is k is 3, 3 power 1 into 1 factorial. So what is this? This is 5, 4, 3, 2 and here 3, 2. So these are cancelled, the answer is 20. This means that 1, 2, 3, 4, 5, that conjugacy class corresponding to this must contain 20 elements. Okay, conjugacy class, if you are using this partition 3 plus 2, then you have this permutation, and corresponding to this permutation in S5 there are 20 elements in its conjugacy class, right? So from here we are getting the full detail, that how many conjugacy class and how many number of elements in a conjugacy class you can see. Okay. Next 5 is 3 plus 1. 5 is equal to 3 plus 1 plus 1. So permutation must be alpha 4 is equal to 1, 2, 3. And this is 1, 1, no need to write if you want to write. This is in fact the type of this permutation. So one cycle of length 3, right? K is equal to 1. So one cycle of size 3, right? So here K is equal to 3 and size is 1, right? Here I am saying size of cycle, but no, in the formula here this is k, this number is k, and it's how many times it is appearing, its size. So 3 is appearing 1 time, so the size of 3 is 1. Okay, so C alpha 4 size of conjugacy class is 5 factorial over, what is this, 3 is k, 3 power 1 into 1 factorial. Now these are 2, so 1 power 2 into 2 factorial, right? Here k, when k is equal to 1, then you have 1 power 2 into 2 factorial. So this is equal to 5, 4, 3, 2, and here is 3, 2. So these are cancelled. Once again 20. See, again you have 20 elements, 1, 2, 3. Okay, so this class corresponding this permutation contain 20 elements. 20 elements. Then for 4 plus 1, number 6, 5 is equal to 4 plus 1. So here alpha 1, 2, 3, 4, 5. Alpha 6. Alpha 6 must be of the type 1, 2, 3, 4, and into 1 no need to write. It means that when k is equal to 4, it is of one size, and k is equal to 1 again is of one size. So the formula is C alpha 6 conjugacy class is 5 factorial over 4 power 1 into 1 factorial and 1 power 1 into 1 factorial. So you have 5, 4, 3, 2, 1 over 4. These are cancelled, that is 30. So you are getting 30 elements corresponding to 1, 2, 3, 4. So corresponding to this, you are getting 30 elements. What does it mean? That the conjugacy class corresponding to this element alpha 6 contain 30 elements, or you can say that there are 30 elements in S5 which are conjugate to this element, or you can say there are 30 elements whose type is of the type of this partition type. No, finally 5. 7 is 5 is equal to 5, and then if you use 5 is equal to 5, so 1 k1 and of one side, of course. So the formula is here alpha 7 must be equal to 1, 2, 3, 4, 5 of the type. Then how many permutation of this type is there in its conjugacy class? You can find with the help of formula. So these are C alpha 7, this is 5 factorial over 5 power 1 into 1 factorial. So this is equal to 5 into 4 factorial into 5, these are cancelled for 24. So there are 24 elements of the type. Right. Now if you add up these elements, you will see that there should be 120 elements, because S5 has 120 element, and since the conjugacy classes is always defines a partition, so there should not be any element overlapping to any two of its conjugacy classes. So very simple is that. Now think 30, 70, 94 and 94, 104, 105 plus 15, 120. Yes, there are 120 elements. So with this understanding, we can also find the conjugacy classes of AN and also the class equation. So from here, we can write the class equation as well. So the class equation is, you already have written the class equation. How can you write the class equation of this is So what was the class equation? N is equal to C alpha 1, order of C alpha 1, plus C alpha 2, plus C alpha 3, plus C alpha 4, plus C alpha 5, plus C alpha 6, plus C alpha 7. This was the class equivalent, right? For S5. So it can be written easily. This is 120 is equal to, now you write 1 plus 15 plus 10 plus 20 plus 20 plus 30 plus 24. So see, this is the class equation for S5. You can write the class equation of S5. So 1 plus 15 plus 10 plus 20 plus 20 plus 30 plus 24. If you add this, it would be 120, and this is in fact the class equation for S4. Without writing the elements of S5, sorry, S5. Now you see, you have seen that without writing the elements of S5, we can find its class equation as well as we can find its conjugacy classes and in fact the partitions. Okay. From these calculations, we are also able to find conjugacy classes of AN. So let's start from A3. Okay. So recall that what was S3. This was 1, 1, 2, 3, 4, 1, 3, 1, 2, 2, 3. And then 1, 2, 3, then 1, 3, 2. Okay. So you know A3, of course, A3 contains even permutations. A3 contains even permutations. So here 1, and then these are the odd permutations. So none of the transposition can be written in AN. So you are free. Okay. So here 1, 2, 3, 1, 2, 3, and then 1, 3, 2. So you see here order of 3 A3 is equal to 6 factorial. Sorry, 3 factorial by 2, which is 3. And you know every group of prime order is cyclic and every cyclic is abelian. So this is abelian. So every element is self-conjugate, is a central element. That's why every element has exactly one element in its conjugacy class. So that's why its conjugacy classes are 1, and this is one class, and the other 1, 2, 3. Of course, this one, and then 1, 3, 2. So there is no doubt that it's 1, 1, order structure is 1. So its class equivalent 3 is equal to 1 plus 1 plus 1. Right? This is the class equivalent for A3. Because A3 was abelian, so every element was self-conjugate. So because it contains exactly one element, which is itself. Now come for A4. A4, okay, for A4, okay, if you write a table first of the type, if you remember what was the type of A4, so you in previous lecture you have calculated the class equation. 24 was 1 plus 6 plus 8, 1 plus 6 plus 8, and plus 3 plus 6 plus 3 plus 6, 9, 17, and 7, 24. So so for S4 has permutation is 1. There was one permutation this. Then there was a permutation 1, 2 type. Then there was a permutation 1, 2. and 3, 4 type. Then there was a permutation 1, 2, 3 type, and then 1, 2, 3, 4 type. Okay. So we have seen that there were 1, 2, 3, 4, 5 conjugacy classes, and if you find the tableau with the help of class formula, you will see that this contain one element, this contain the conjugacy class corresponding to this particular element is containing 6 element, and this is containing 8 element, this one is containing 3 element, and this one containing 6 elements. Of course, when you want to find conjugacy classes for A4, we will not consider odd permutations. So this can be omitted, odd permutation, right? And then the rest of the permutations all are even. Okay, so this can be omitted, right? 1, 2, 3, 4. So this one is the even permutation, this one is the even permutation. Okay. Now you see, if you find the conjugacy classes for A4, this would be the one class, because identity is self-conjugate, and of course it will contain just one element in its conjugacy class. Then 1, 2, 3, 4. There are 8 elements. Okay, so the conjugacy class corresponding to this element 1, 2, 3, 4 must contain in S4. In S4, 1, 2, 3, 4. This is for so I think we have a little wrong tableau. There were 1, 2, there were 6 element, and 1, 2, 3, there were 8 element. This was 8, this was 3. Oh, sorry. 1, 2, 3, 4, there were 3 elements. Of course, 1, 2, 3, 4, and 1, 3, 2, 4, and then 1, 4, 2, 3. These were the 3 elements. Okay, these were the 3 elements. In fact, 1, 2, 3, there are 8 elements, and these are not the even permutation. We will not consider. So you can consider this, and this. So these all of one type, of course, they must be in one class. This means that if you find a tableau, then 1, 2, 3, 4, this has one element, and this has 3 elements. Whereas this one, 1, 2, 3, 1, 2, 3, and 1, 3, 2. These are the can be separated into 2 different classes in A4. You see that that 1, 2, 3 in fact is equal to, if you see the conjugate element of 1, 2, 3, this was with 2, 3. So 1, 2, 3, if you multiply 1, 2, 3, 2, 3, and then 2, 3 inverse, you will get 1, 3, 2. But remember, 2, 3 is odd, so it does not belong to A4. That's why 1, 2, 3 is not conjugate to 1, 3, 2. Right? They are not conjugate. So it's very interesting that both the elements 1, 2, 3 and 1, 3, 2 are appearing in a same class in S4, but in A4, these were the classes for S4, and these are the classes for A4. Okay, so both were appearing in the same conjugacy class for S4, but for A4 they are not appearing in the same class, because 1, 2, 3 is not conjugate to 1, 3, 2 in A4, because 2, 3 is not an element of A4. So this was the only chance where you can achieve the conjugate with this 2, 3 as 1, 3, 2, and but 2, 3 is not an element of A4. Therefore, we will not consider these two in one class, so they must be split in two. So that's why, since they are 8, so 4 will be here and 4 would be here. So this is the class equation for A4. So class equation of A4 is equal to, this is, this is equal to 4 factorial by 2, which is 12, which is equal to 1 plus 3 plus 4 plus 4. This is equal to 8 and 12. Yes. So this one is the class equation for A4, right? Now I can write directly I can write a tableau, and from tableau you can practice the rest of the examples like S5, A5 and then A6. In this way you can see, first write the partitions, then write the types of permutations, then corresponding to every permutation you can find the size of the conjugacy class, right? So in this way, then after you can see that which one of them, those are even and which one of those are odd. Then after you will see that some are appearing in a same conjugacy class in Sn, but they are not appearing in the same class in An. So those, they are not conjugate to each other in An, can be separated into two equal classes like this. You have broken 1, 2, 3, 4 this class into two classes in A4, and both are containing 4 elements, because in S4 there were 8 elements, so that's why these are the conjugacy classes for A4. Next I will write a tableau to understand the idea. So you can complete left as an exercise. I will write the tableau and you try to verify this tableau whether I have written the right table or there are some mistakes. So try to complete this table for S5. If you find S5, for S5, of course permutation must be 1, then 1, 2, then 1, 2, 3, 1, 2, 3, then 1, 2, 3, 4. Here 1 is the fixed point, 5 is fixed. Here 2 are fixed, 4 is fixed, 5 is fixed. Here 3 are fixed. Here 4 are fixed. All are fixed, right? This is identity. Okay, so 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, yes. 1, 2, 3, 4. Then 1, 2, 3, 4, 5. Here 1 is fixed. 1, 2, 3 and 4, 5. This can also be written as 1, 2 into 3, 4, 5, no problem, because I want to give the type. That's why both are the same ideas, no problem. So I am writing 1, 2, 3 and 4, 5, because you have the product in your formula. Either you are using first size first or after, because multiplication is commutative, so that's why we will not have any difference between these two. Okay, this is the reason. So 1, 2, 3, 4, 5. Next is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And these were the possible classification of conjugacy classes. So 1, 2, 3, 4, 5, 6, 7. There were 7 conjugacy classes you have seen in last lecture. So their sizes were 1 and then 10, 1, 2, 10, 20, 1, 2, 3, 20. I just has calculated. 1, 2, 3, 4, 50. These were 50. And 1, 2, 3, 4. 1, 2, 3, 4. These were 30. Okay. Then 1, 2, 3, 4, 5. There are 20 elements in its conjugacy class, and there are 24 elements. So what was the class equation? Well, class equation was 5 factorial, which was, I think, 120 is equal to 1 plus 10 plus 20 plus 15 plus 30 plus 20 plus 24. Okay, this is the class equation for S5. Now for A5, for A5, you will see the permutation. This is E1, this is E1, 1, 2, 3. We will not consider this. So this is odd permutation. This one is odd permutation. Okay. And for S5, right, 2 plus 1, 3. This one, 1, 2, 3, 4, 5, 4. Yes, this is okay. This one, this is odd permutation. Okay, even odd permutation we will consider. So again, you will see that all are appearing in 1. There are 1. There are 1, and there are 20, and then this 1, 2, 3, 4. All are identical in A4 as well, appearing in the same cycle. 15, but these would be split into 2, right? Because you will see that 1, 2, 3, 4, 5 and 2, 1, 3, 4, 5 are not conjugate to each other. This one must be split into 2. One is 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the other is 2, 1, 3, 4, 5. You can check this. They both are not conjugate to each other. That's why this 24 would be split in 2 classes of 12, 12, right? So the class equivalent is equal to A5, order of A5, which was 5 factorial by 2, which was 120 by 2, which was 60. And you can count this 60. This is equal to 1 plus 20 plus 15 plus 12 plus 12. Right? So what are these? 21, 26, 36, 38, 48, 50, 60. Yes, this is the class equation for A5. Similarly, I can write class equation for A6 and class equation for S6. And you have to verify and you need to calculate these classes for S7 and A7. You can verify because remember A7 is a billion, right? So the class equation for A7 is so simple. Every class must contain just one element because all elements of A7 are the central elements or the self-conjugate elements. Okay, next is S6. S6. So for S6 you have 1, 1, 2, 1, 2, 3, then what it could be 1, 2, 3, 4, 1, 2, 3, 4, this, next there must be 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, or you can write 1, 2, 3, 4, 5. One is the same thing, no problem. Then 1, 2, 3, 4, 5. Then after 1, 2, 3, 4, 5. Afterwards 1, 2, 1, 2, 3, 4, 5. So then after you can write 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Then 1, 2, 3, 4, 5, 6. Yes, it is. 1, 2, 3, 4, 5, 6. This is another type. And then 1, 2, 3, 4, 5, 6. And last would be 1, 2, 3, 4, 5, 6. Yes. Now similarly, by using the formula, you can find the number of elements. So these are 1, 15, 40, 45. 1, there are 1 and 1, 15, 40, 45, 45, 1, 2, 3, 4, 45, and then 1, 2, 3, 4 is 90. And there are 90 elements in its conjugacy class. And then 1, 2, 3, 4, 5 is 144. 1, 2, 3, 4, 5. There are 144. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, and then 90 elements. There are 90 elements in 1, 2, 3, 4, 5, 6. 3, 4, 5, 6 contains 15 elements. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. There are 15 elements again. 4, 5, 6. There are 40 elements. There are 15 elements. 3, 4, 5. So this has 90 elements. And lastly, this has 1, 2, 3, 120 elements. 120. So the class equation is, you can write the class equation 6 factorial, which is equal to 720, which is equal to 1 plus 15 plus 40 plus 45 plus 90 plus 90 plus 144 plus 90 plus 15 plus 40 plus 120. Okay, let me verify. Corresponding to 1, 2, you have 15. 1, 2, 3, you have 40. 1, 2, 3, 4, you have 45, yes. And 1, 2, 3, 4, you have 90 elements. 1, 2, 3, 4, 5. 1, 2, 3, 144, yes. And then 1, 2, 3, 4, 5, 6. 90 and 1, 2, 3, 4, 5, 6, and 15, and then 1, 2, 3, 4, 5, 6, 40 elements, and 1, 2, 3, 4, 5, 6 is 120 elements. Okay, yes, you can find everything of the type from a software gap, but I want to tell you what the logic behind that software. So you should be able to evaluate these things yourself, by yourself. You should know the formula, what is the formula we are using in that software. Okay, so that's why you must have to practice for 1 or 2 examples, for 1 or 2 bigger examples. Okay, this is the class equation for you just verify that whether sum of these is 720. Similarly for A4, for S6, A6, right? For A6, you can write permutations. So you have to cancel out, this is not odd, right? This is not odd. 1, 2, 3, 4, 5. This is not odd. 5, 3, 4, 5, 6, 3, 1, 4. This is not odd. 6. This is not odd. Okay. So there are remaining, it could be 1 and then 1, 2, 3 and then 1, 2, 3, 4, 1, 2, 3, 4 and then this one 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This could be distributed into 2 1 2 3 4 5, and the other is 2 3 4 5 6. 2 3 4 5 6. Again you will see that both are not conjugate to each other. 1 2 3 4 5, 1 2 3 4 5. Permutation of length cycle of length 5, of course, can be split into 4 transpositions. So they are not conjugate to each other. You can verify this. Okay. And so these were 144. So 72 must be here and 72 must be here in equally. So this class would be separated into 2 equal subclasses in A4, right? But all work together in A6, but all work together in S6, right? Similarly, what are the other 1 2 3 4 5 6? 1 2 3 4 5 6. So 1 2 3 4 5 6. What is the next? Next one is 1 2 3. 1 2 3 4 5 6. Right. This is 1. This is 40. These are 45. And these are 72. And again 72. And these are 90. And these are 40. Yes. Now we can write the classic name. This is equal to A6, order of A6 is equal to 6 factorial by 2, which is 720 by 2, which is equal to 340, and which is equal to 1 plus 40 plus 45 plus 72 plus 72 plus 90 plus 40. Okay, you can verify that this is equal to 340. This is the class equivalent for A6, and this is the class equivalent for S6. Yes, you have seen that without writing the elements of Sn, just by using the formulas for partition, you can enjoy the concept. It's very beautiful. You can enjoy the formula. These are very beautiful formulas, and credit goes to those they have established a relation between Sn and the partition, unordered partitions. Okay, so next time we will have some theorems related to conjugacy classes. Okay, try to solve class equivalent for S7 and a class equivalent for A7. And the class equivalent for A7 is so simple, no problem. Thank you very much. Allah Hafiz.